Today I'm going to be explaining Chapter 11, Describing Chemical Reactions. Okay, so a chemical reaction is the process of rearranging chemical bonds, and also reactants interact to form products. So, what it would look like is a reactant forms and interacts into a product. Okay, so now this chart, which you can find on page 348, it has symbols and then an explanation. So the first symbol, which is a plus sign, it just separates two reactants or two products. The second symbol, which is an arrow, it symbolizes a yield sign, which separates reactants from products. The third symbol is like two reversed arrows, which it pretty much just symbolizes reversible reactions. For the lowercase s, l, and g, that symbolizes a solid state, liquid state, and gaseous state, and is placed after the formula. The AQ in the parentheses, it just designates an aqueous solution. The two arrows with the little triangle and the heat sign above it indicates that heat is supplied to the reaction. And then the arrow with the PT above it, it is a formula above or below the yield sign that indicates its use as a catalyst, and in this example is platinum. So going up back to this equation where it's R yields to reactants yields to products, this arrow is where the catalyst would go, and a catalyst, pretty much what it does is it speeds up a reaction. Okay, so I'm going to briefly go through the skeleton reaction and what it is. It's a chemical equation that does not indicate the relative amounts of the reactants and products. So pretty much what you do is you separate the reactions on the left, the products on the right, and then you the atoms that you have, the elements, you determine if they're a solid, liquid, gas, or like an aqueous solution, and whatever they are, you put a parentheses by the element, and then, so like, for example, right here, that S right there, that signifies it's a solid. The AQ there signifies it's an aqueous solution. The AQ there, aqueous, the L is a liquid, and then the G is a gas. And this is just an example from the book right here. Alright, so we're now going to learn how to balance chemical equations. So, obviously you're going to start with the reactants on the left side and the products on the right side. So, for the first example, we're going to do C, which is a carbon atom, plus O2, which is an oxygen atom, which yields to CO2. Alright, so for this one, the formula for the reactants and products are correct, and we're going to see if it's balanced. So on the left side, there's one carbon, and then there is two oxygens. So let's see what's on the right side. One carbon, two oxygens. So this was an easy one because it's already balanced. The point of it is you have to make what's on this side, you have to make it equal so what's on the left side you have to make equal to what's on the right side. So since there's one carbon on the left side, one carbon on the right side, two oxygens on the left side, and then two oxygens on the right side, that makes it equal. So that was an easy problem. So now we're going to do another problem. H2 plus O2 yields into H2O. Okay, now this one, the formula for the reactants and products are correct, but the second equation, or this equation right here, it's not balanced. So, in order to balance it, let's start out with seeing how many we have. We have two hydrogens and two oxygens on the left side. Now on the right side, we have two hydrogens, which matches up, but we have no oxygens. So, in order to get that to balance, we need to add 2. So, we add a 2 in front of the H2O, which gives an oxygen 2, But now that we put that 2 there, we have 4 hydrogens because 2 times 2 is 4. So, in order to balance that, you'd go back to the left side and add a 2 right here, which hopefully balances it. Let's see. 2 hydrogens right here, or actually 4 because you multiply it. It's 4 hydrogens plus 2 oxygens, which yields to 4 hydrogens and 2 oxygens. So, perfect. That's a balanced equation right there. Okay, so this is a balancing chemical equations part 2 slide. A definition right here is law of conservation of mass or matter, and it means that matter cannot be created nor destroyed. A coefficient, which I forgot to mention in the last slide, is the number that goes in front of the elements. So here, here, and here is a coefficient, and then the smaller numbers like this 3, this 2 right there, the 2 right there, those are called those exponents. Those are called exponents. So now that we have that settled, we're going to balance this equation right here. So we'll start out. This is a little bit harder of a problem than we've been doing, so we're going to start out here. So Fe, 1 Fe on the left, 2 oxygens on the right. On the left, sorry. But here there's 2 Fe's and then there's 3 oxygens. So obviously this needs to be balanced. So since there's 1 Fe on the left and then 0 Fe's on the left, 2 Fe's on the right, we're going to add a 2 right here. So that right now is balanced. Now we're going to move on to the O2 right here. So since there's 2 here, but then there's 3 here, we're going to take that 3, move it over here. So now we have 6 right here. And then we're going to take this 2 that's right there, and we're going to put it right here. So they both multiply out to equal 6. So they're both equal now. So now we have a little problem because we had our Fe was equal, but now it's not anymore because we added that 2. So now we have 4 Fe's on right here. We have 4 because you multiply the exponent times the coefficient. So you have 4 Fe's on the right side. But it's pretty simple. All you need to do is go back to the left side to this Fe, and you just, erase that 2 and then make it a 4. So the final balanced equation is going to be 4 Fe plus 3 O2, which yields to 4 Fe, and then O3. So, with that being said, this right here is a balanced equation. So the next thing I'm going to explain are the 5 types of chemical equations. So the first one is combination, the second one is decomposition, the third one is single replacement, the fourth one is double replacement, and then the fifth one is combustion. Okay, so the first 2 that I'm going to explain are combination and decomposition. So for combination, it's 2 or more substances form a single new substance. For decomposition, it is a reaction in which a single compound breaks into 2 or more products. So for combination, this is the example I have here. So it's pretty much what it does. It combines, like the name combination, the 2 elements into one. So there is Mg and O2. So what you do is you just combine them and you get MgO. And since there's 2 in each of them, you just need to put a 2 right there because that already gives it 2. So yeah, that's combination, pretty simple. Now decomposition is pretty much the opposite of combination. You start out with the combined form right here, and then you're going to end up with, as the product, with 2 elements that you separated from the combined form. So since you have H2O2, that what you're going to do, you have 2 H2O2, you're going to separate them into 2 H2O plus O2. So, I mean, that's all you pretty much do for that one is just separate the two elements. Okay, so the next two I'm going to explain, the next two reactions are single replacement and double replacement. So the single replacement is a reaction in which one element replaces a second. So in this example, you can see that the Zn and Cu, once you yield it into the product, all it did was switch it. So the Zn and Cu on the left side just switched onto the right side. So it went from Zn plus Cu to Cu plus Zn. The NO3 stayed right where it was. So that's all you got to do. Switch those first two right there. Now for double replacement, it's a reaction in which the positive ions exchange. So an example right here, you take the two positive ions, by the way, are the first two. So Na and Cd, first two. So once you switch it, you're going to have, you switch the Cd with the Na. So you have CdS plus 2 NaNO3. So that's all you did. You switched the Na right there with the Cd right there, and you end up getting CdS plus 2 NaNO3. So yeah, that is an example of a double replacement problem. Okay, so the last reaction I'm going to explain is combustion. And combustion is a reaction in which the compound or element reacts with oxygen and produces heat. So I have an example right here. It's 2C8H10 plus 2SO2 yields to 16CO2 plus 18H2O. So in the definition, it says that it reacts with oxygen and produces heat. So that's very important. You need to know that. So pretty much combustion in the reactant, remember reactant is this side and then product is this side. In the reactant, you will always have an oxygen somewhere. And in this example, it's right there because it reacts with oxygen. In the product, it produces heat. So since it produces heat, you're always going to have CO2 plus H2O because that is heat. You're just always going to have that. So since you know you have CO2 and H2O and you know you have O2, pretty much from there, what you do is just balance the equation and then you should be good with combustion. Just remember, main thing is reacts with oxygen and produces heat. Okay, so for ionic equations, most reactions are done in H2O, water. Also, it is most common in double and single replacement. For complete ionic, it splits up the aqueous. Spectator ions are ions that appear on both sides. For net ionic, only parts that make up chemical reactions, and then they always start with a balanced equation. And then I added this chart here. It's the solubility rules for ionic compounds. For ionic compounds, you need to know if it's insoluble or soluble. So this chart is a lot of help with that. And yeah, that's the end of my project. Thank you.